Hey everybody, welcome back to Welding Wednesdays. This week we're going to do all about applications and terminology. So, a couple things before we start. Kind of the idea behind this is to really help us build out like some of our vocabulary and things you might hear out in the workplace, whether you are on the supply side, like MO2 is, with vending and stuff like that, or if you are new to the industry, kind of coming out of school or something like that, just so you kind of have an idea of what some of the lingo might be out there, because it can be sometimes intimidating. So let's get started. Right. So starting off with welding applications. Uh, we're going to focus on 5 processes throughout all these Welding Wednesdays that we're doing. These are the 5 that I've really identified as the primary welding processes that our customers use, but also I think what most people will be seeing out there in the world. So first off is SMAW, also known as stick, GMAW, also known as MIG, GTAW, also known as TIG, FCAW, also known as flux core and arc welding, and then OFW/OAW, that's going to be oxyfuel welding or oxyacetylene welding. If we look at SMAW, also known as stick welding, why is it called stick welding? 2 things that I've heard are, number one, when you're trying to start it, especially when you are first getting into the welding industry, you're going to stick the rod to your workpiece and then get really angry about it, usually. So that is one place where stick comes from. The other would be the actual, like, rod looks like a stick. So those are the 2 things I've heard. If you've heard anything else, please let me know, because I'd like to learn more myself. It uses a consumable electrode, so we're going to look at the difference between electrodes and fillers, and how they're the same and how they're different. So this is a consumable electrode. It's got a metal core surrounded by flux. Some advantages of SMAW are portability and low cost. Some disadvantages are it's slow and lots of waste. Depending on how good you are at stick welding, will really influence how much of your rod actually gets into what you're welding. So I think on average, it's about 2/3 to 3/4 of the rod is used for most people. So that means that we're going to be wasting about a quarter of a rod to 1/3 of the rod every time we weld, which is a lot. It adds up quick. Some common applications are construction, repair, pipeline, really great out there in the world. I would say stick is like my probably favorite type of welding to do. It's not the one I'm best at. Well, I might not be very good at any of them. Who knows? That's other people's. Other people can decide that, I guess, maybe. But I enjoy doing stick the most. All right, GMAW, also known as MIG, uses a consumable combined electrode and filler. So when we talk about something like this, and like with SMAW, your electrode is what conducts the electricity into where the weld is happening, and then the filler is what gets melted with your base material to form your joint. So in stick, your electrode and filler were the same thing. GMAW, electrode and filler are the same thing. You need shielding gas to protect your weld metal. In SMAW, you have the flux. The flux melts and creates a shielding gas to prevent atmosphere from getting into your weld. And also, the flux helps to clean out any contamination in your weld. So it's really great if you have something like dirty. You should always be prepping your material well, but we can't always do that. So if you have kind of dirtier metal, stick is great because that flux cleans everything out. With GMAW, if you watched the previous Welding Wednesday, you'll remember we talked kind of about the history of welding and how wire feed or GMAW welding was invented itself about 30 years before they started using shielding gas. So it was used as like a bare metal for quite a long time. Some advantages are it's fast and efficient. You're using all your material, really. There's very little waste. You can move really fast because you got usually like a big spool of wire, so you don't have to keep on switching out your electrodes like you have to do with stick. It's also overall simpler to learn. Personally, I try not to use the words like easy or hard because those are really relative. What's easy for me might be hard for you and vice versa. Try to use simple and complicated because, something simple could be easy or hard, complicated, easy or hard. MIG welding is pretty simple as far as like what goes into it and what you have to know, but it can be difficult to learn. I know for me, for whatever reason, I really struggled with understanding how to adjust your wire feed speed and voltage to get where you want. So it was a simple process, but one that was kind of hard for me. Later on in this series, we're going to delve really deep into each type of process and then go into what's involved, machinery, everything like that. So if you want to learn more about one of these 5, we're going to go deep into it. Some disadvantages of GMAW is it's not very portable. You got usually bigger machine, maybe, you have an external or internal wire feeder, you got your shielding gas, harder to get around. And it can be limited to certain material thicknesses depending on transfer method. This is something I see all the time where people are not using, I'll say, the optimal transfer method for the type of material and thickness they're welding. Great example is short circuit. That's the transfer method that is most commonly used, I would say, with GMAW. Not really suggested for much over like 1/8 of an inch if you're doing structural steel. I know, most things when say don't really use it over 3/16. It's definitely for a thinner type of metal or a heavily prepared weld joint. Some common applications, you see it in automotive. Any sort of automation is probably going to be using wire feed or MIG to be able to dispense that wire, and most mass production manufacturing. So I would say the majority of our customers are probably using GMAW as far as their process when they're welding. One note on the name. So GMAW is gas metal arc welding. MIG is metal inert gas welding. So the reason we go to GMAW now, or GMAW, is because we can use active gases. So like a 75-25 gas mix, which is very common. That's a 75% argon, 25% CO2. That 25% CO2 is an active gas. So the GMAW is a more accurate name than MIG, but you're going to hear MIG everywhere. And you'll hear me just kind of switch them out as I feel when I'm talking. GTAW, very similar as far as the naming convention. So GTAW is the gas tungsten arc welding. TIG is tungsten inert gas. Same reason that we could have active gases involved, which we'll go ahead and make that TIG not a accurate name. We're using a separate electrode and filler in this case. So in one hand, if we look at these photos up here, so like this one up here, we can see in the one hand is a torch. At the end of that torch is a tungsten electrode. That's what's going to be conducting electricity into the weld. That's not supposed to become part of the joint, but any of you who have TIG welded in the past know that's tough to do, especially when you're first starting out. You're going to dip that thing a ton. And your other hand here, we can see we're adding our filler in. The filler that's used for TIG is the exact same that's used for MIG. It's just MIG is also going to conduct the electricity, and it's usually on like a roll or a spool. TIG is cut into straight lengths that are usually 36 inches all long. You need shielding gas to protect the weld metal. You don't have any flux or anything like that. Advantages is it's very precise, and you can weld difficult materials. You can do your steel, but it really helps with like stainless, aluminum. You can do magnesium, titanium, lots of different materials. Some disadvantages are it's difficult to learn and consistently make quality welds. And what I mean by that is like, even if you're really good at GTAW and you've done it a ton, you have to put in a lot of work to make a consistent weld. Like no matter how talented you are, the people who are the most talented with the most practice, they'll make it look easy. but everything matters when you TIG weld. You know, the material, the atmosphere around you, humidity, the quality of the filler, the tungsten, you know, your settings, all these sort of things, everything figures in. I kind of like to think of it like stick you can get away with a lot because of the flux, because you're welding like thicker things. You know, there's a lot more leeway as far as variables. For MIG, there's less, but once you get the MIG machine set, you can really just crank things out. No problem. TIG, to me, it's always changing. It's always so, like, fragile, persnickety. I don't know what the right word is, but it just, it takes a lot of work to make that consistency, no matter how good you are at it. So people who are really highly skilled TIG welders, especially with like stainless, aerospace, things like that, very, very, very talented. It's also very slow. So if we think about like inches per minute, as far as like how much you can weld in a minute in a perfect scenario, if you're TIG welding, you're looking at like 4 to 6, maybe inches a minute. If you're MIG welding, you're going to look at like, it's usually maybe like 6, 10, 12, something, somewhere in there. It really depends on thickness, process, your transfer method, all that sort of stuff. You compare it to something like laser welding, then you're getting up to like 20, 50, 100 inches a minute. So it's a very slow process. Common applications, like I said earlier, aerospace, reactors, any sort of pressure piping, that's going to be using TIG. All right, FCAW, so that's flux cored arc welding. This uses a consumable combined electrode and filler. It's kind of like a mix of your MIG and stick. So the actual filler is a hollow wire that has flux inside. So it's kind of like an inside out stick electrode. And then it's ran on a MIG machine. So it's on a spool, dispensed the same way with a gun. Squeeze the trigger, out comes your wire, your electricity, and your gas. You can need shielding gas to protect the weld metal depending on the type of flux core. So there's 2 types. There's the self-shielded. So again, that works just like a stick weld where the shielding is provided by the flux. And then there's dual shield. That's where you're going to have the flux and a shielding gas. I love dual shield flux core because you can make really awesome welds that look great and are super clean, super high quality, things like that. I believe worldwide, flux cord, at least cord wire, is used more than any other type of wire. So GMAW, I think, probably would be your most used process. Flux core puts down more wire in a year than probably anything else. It's great for big joints, great for construction things, all sorts of stuff like that. So advantages, a high deposition rate. We're putting down a ton of metal fast. That's what deposition is. And then you can use it in all positions. Some disadvantages are you're at a much higher voltage than you usually are with MIG. So you can have really high fumes from the arc intensity. A lot of times if you're going to be welding flux core, let's say you have a welding helmet, maybe you're at a shade 10 when you're doing other types of welding. Flux core, you're going to be like at a 12 or 13. It's way brighter, way more energy. And that creates way more fumes. Some common applications are construction or shipbuilding. Very, very common in those. I missed one disadvantage. It's also higher cost. So wire is a bit more expensive, you know, that sort of thing than GMAW or SMAW. Lastly is oxy-fuel welding or oxy-acetylene welding. So I included this not because there's like a ton of people who do it, but at least in our world, we have a lot of HVAC companies that will use this to help supply materials, industrial gases, that sort of thing. And they do a decent amount of oxy-fuel welding. This is also similar to like a brazing or a soldering type application. So the main difference between soldering, brazing, and welding is the temperature at which they're done at. So soldering is like a lower temperature, brazing is like medium, and then welding is like high temperature. Also in soldering and brazing, you're really taking like 2 pieces of metal, and then you're introducing a third different metal, or I guess a second different kind of metal. But you are kind of gluing your base metal together. Whereas in welding, you're actually taking your base metal, combining it with filler, and you're making a brand new, basically, joint. So if we think about, brazing something, you have two pieces, you're gluing them together, you still have two pieces of metal basically glued together, which is very simplistic, I know, but, pretty accurate. But with welding, we'll take our two pieces of base metal and our filler, we melt them all together, now we have one piece of metal. And I think that's really important for people to understand, because the welding is what allows us to do a lot of different things as far as construction, manufacturing, stuff like that, because you're actually joining multiple pieces of metal to make one piece of metal. Some advantages, or you can use multiple fuel gases, so propylene, propane, MAP gas, things like that, acetylene. Some advantages, you got precise control and less heat and UV radiation. So if you look at the pictures here, a lot less protective gear. If things are relatively clean, a lot less fumes, things like that. I personally am a huge fan, if you have the opportunity, of oxy-fuel welding being one of the first processes you learn, because it allows you like a very controlled, kind of quiet environment, I would say, to be able to really learn what a weld puddle is, how to manipulate it, what your heat input does, things like that. And especially if you're going to go into TIG later, like doing oxy-fuel, super, super helpful if you can do it. Some disadvantages, it's very slow. It's limited to thinner materials. You're not going to be able to do really, really thick stuff with it. Some common applications, like I said, were HVAC or fusing a thin sheet metal, and a lot of repair. If you're doing things like cast iron repair or things where you really need to control your heat input, this is a good process for that. All right, let's look at some terminology. So I'm going to talk a bit about common terminology, and then we'll talk a little bit about slang. So some common terms, just to make sure, again, we're all using the same things, understand what we're talking about. First one's base metal, so that's going to be your material welded. So if we look up here, we got one side of base metal here, second side of base metal here. Ooh, great drawing. And then in the middle, that's where they're joined with the weld joint. So our base metal is joined with our weld joint. The weld pool is the molten area during welding. So if we look in this picture, this is the weld pool or the weld puddle. It's kind of obstructed here by your arc, or in this picture by the arc. Depending on the type of process you're doing, your position, things like that, the puddle will not be right underneath your arc. And in fact, it's kind of hard to explain, but the arc can be really distracting. The puddle is what we're really focusing on. So the puddle and the manipulation of the puddle is going to make sure that we get the fusion, the penetration, the appearance, everything we want. It's all about that puddle. For filler metal, that's material added to create the weld joint. So if we look here, we got some base metal, number 1, number 2, and then everything in between the two, that's your filler that has been melted to join. And then electrode, that's a consumable or non-consumable that carries the current to melt the base and the filler metal. So this picture down here, we have some electrode and filler. The straight links are filler for TIG. These spools would be electrode for MIG. All right, some more common terms. Shielding gas, MO2's primary business. It's a protective gas used to prevent atmospheric contamination. Many different types of shielding gases have been used in the day. Let's take TIG, for instance. That started out as a type of welding process called heliarc because helium was used. Helium is still used in TIG, especially if you're doing thicker aluminum, things like that. It allows more heat to kind of get through thicker material. But helium is pretty expensive, and when you use it, it floats away and disappears. So we use a lot of other alternatives that are more cost-effective and are at least as good, if not better, most of the time. So things like argon, CO2, nitrogen. If you're doing laser welding, you can have a little oxygen, depending on the type of mix. that helps with like stainless steel, like a 98.2 MIG mix, like things like that. So many different types. Main thing is the shielding gas is going to protect your weld from the outside atmosphere, so we're not getting a bunch of contamination and or other gases into our molten weld metal. And it's also going to help to like shape your bead and MIG. It allows for different transfer methods. Shielding gas does a ton for you. Your arc, that's the area of electrical energy between electrode and the base metal. So out of the 5 processes we talked about earlier, 4 of them are arc welding processes where you're using electricity to make your weld. So if we look at this picture right here, this would be the arc right there. Polarity is the direction of the electrical current flow, and depending on your welding process, you're going to have a different polarity. Also, like depending on your type of filler, the material you're welded on, those all affect polarity. There's 3 polarities that we're going to deal with. One is DCEN, that's direct current electrode negative, also known as straight polarity. You have DCEP, so that's direct current electrode positive, also known as reverse polarity. And then you have AC, or alternating current. That's where we go back and forth between the two. And then bead, that's the deposit of your filler metal in your weld joint. So if we look at this one down here, this fancy looking weave they put on, that would be your bead. All right, some other common terms, slag. So if we're doing stick welding, once that flux melts, creates the shielding, it also is in our weld metal. As that weld metal solidifies, the flux rises to the surface, and then it goes and like collects and solidifies on top of the surface. Super useful because not only is it removing impurities, it's protecting the weld and it's slowing the cooling rate, which will allow for stronger weld. So what's left after all that's done is called slag, and that's what you chip off if you're doing flux core or stick or anything with flux. So this top picture here, we see a chipping hammer, that shiny, good looking weld metal underneath, and then, whoop, there we go. We got our piece of slag there that we chipped off, and I would say that's a flux core weld based on the type of bead. If you don't think so, let me know, but pretty sure that's what that is. Porosity, that's small holes in the weld from trapped gas. So this bottom picture here is just chock full of porosity. That's going to be from inadequate shielding, allowing that atmosphere to get in. Contamination on your actual base metal will do it. So like oils, water, anything like that, anything organic can help create that porosity. Bad, don't want it. Spatter is tiny drops of metal outside the weld zone. So like right here, this is all spatter. Commonly confused with splatter. It is not splatter. It is spatter. Spatter is going to be caused by the prep of your material, different types of shielding gas, transfer method, things like that. If you're too close, too far away, lots of stuff can make spatter. Just like porosity, we want to try to limit it. Less spatter most often will mean better welding technique, better quality welds. And then fusion, that's melting material to make a solid joint. So our last photo here, where that joint is in the middle, that's where we have our fusion. Fusion's a big deal. I would say, like fusion and penetration. Those are 2 things you really gotta understand when it comes to your welding, because that's what's going to make sure you have that good quality structural high strength joint you're going for. All right, some slang terms to finish things off. Today we got stacking dimes. So that's neat overlapped circular beads. So this photo at the bottom here, those are some good looking stacked dimes. That just shows good movement, good consistency. I will tell you, in my opinion and from what I've learned, if a weld looks like that, odds are it's a good quality weld. But just because a weld looks like that does not mean that what's underneath is good. So like a good surface looking weld probably means your weld is good all the way through. But this is why when we do inspections, when we do things like that, we'll do different sorts of non-destructive testing, destructive testing, because you can cover up a poor quality weld with a great looking cover pass. It is possible. So that's just for appearance. That's not about our structural like weld. Frying bacon, that's the sound when you MIG weld. So it should be like a sizzling sound when you're doing the short circuit transfer method with an occasional pop. That's telling you you're right where your settings want to be. There's a ton of like listening and hearing that really can help out with welding once you start to like key in on the different things. A golden arm, that's a welder with excellent technique. So I would say most people who, well, if anyone would ever call themselves a golden arm, they're probably just very conceited. But yeah, golden arm is excellent technique, very high quality welder. Let other people call you that. Bubblegum, bird poop, dingleberries. So that's a poor quality weld that looks like those things. So in this photo up here, that is just nasty looking. And over here, same sort of thing. High crown, a lot of overlap, probably little fusion, bad consistency. Yeah, not very good quality welds. Now, the same thing as I said with the stacked dime. A weld that looks like that does not necessarily mean it's like bad. It all depends on the application. But if a weld looks like that, you're probably not meeting the intent of the application. If that kind of makes sense. If you need more to like explanation for that, get a hold of me. I'll kind of try to suss it out a bit more for you. But all right, more slang terms. Stringer, that's a straight weld bead, no weave. So right up in this photo, these are stringers. So very little like side to side motion. BBs or buckshot, that's small balls of spatter usually generated from MIG welding. So right here, we see some BBs, buckshot. They don't always have to like stick. You know, you can just produce like small little BBs that fly off. So usually settings not right, technique's not right, something like that if you're getting a lot of it. Bird's nest is a tangle of wire inside of a MIG machine. So this photo right here has a bird's nest. Tons of stuff can cause a bird's nest. Dirty wire, rollers, wrong size rollers, tension too tight or too loose, obstructions in your conduit, something wrong with the contact tip at the end, lots of different stuff. So relatively common problem, and one that is easy to solve, I would say, or simple to solve, but there's a lot of things it could be. So you have to kind of go down a checklist to find what it is. And then a brother-in-law weld. This is a weld done by two welders at the same time, very common in pipeline. So we see in this photo here, we got a pipe and two people are welding on each side using SMAW. So that's going to be a brother-in-law weld. And I believe this is our last, this is our last term for the day. So pancake, that's a welding hood that is round and flat. So right here, pretty unique, used by a lot of pipeliners. You can see this guy with his own rig down here, or I should say their own rig down there. The pancake, it really helps with like, from what I've been told, I've never used one, I've never welded pipeline, but it really helps with like weight if you have to wear it all day. Usually they're made out of like balsa wood, so much lighter. Really can focus on what you're doing, less glare, cooler because you're open on the sides, things like that. So if you're welding, using this, you just got to make sure that you're not having like UV light that's going to be bouncing off, hitting the parts of your face that's not protected, because we don't want to do that. But yeah, great choice for those of you who are working outside and working on pipe, and you're really welding all day, where you need something that is more something that's lighter and just allows you to move better. Rig is going to be your outfitted mobile welding truck. So at the bottom here, this person, that's their rig. Depending on where you're at, I know a few years ago you can make a ton of money running your own rig. Would assume it's the same, but I don't have that experience. The downside is the dollars might look awesome because you're making a ton, but you're in charge of all your overhead. So before you think about investing in your own rig, be aware of that. Walking the cup. So that's up here. That's a pipe welding technique. I'll tell you what, teaching new welders, a lot of times they'll be like, ooh, saw walking the cup, saw this on Instagram, saw this on TikTok, whatever. Looks awesome. I always tell them, like, we got to walk before we run. We got to crawl before we walk, actually. So we're going to focus on, initiating arcs, good movement, and stringer beads. Stringer beads will, like, never fail you. They're going to help with the best, make the best structural welds. They're, like, super reliable. Things like walking the cup and techniques like that, very useful in some industries. So I know pipe fitters, very useful. Great to make a very nice looking cover pass. But one thing you just need to be aware of is the more you manipulate your electrode, the more you move it around, the more you will affect your penetration. Doesn't mean you're doing something wrong, doesn't mean the weld won't work, but just be aware that the more we're moving our electrode or our torch or whatever from side to side, we are going to be affecting our penetration to some extent. And then finally, final term is Zorro. So that's a welder attempting to unstick a stick electrode. So you'll see it if you've done it before. You'll see other people do it. You get your electrode stuck. It's on your piece of metal, and then people all trying to shake it off, making almost like a little Z. That's the Zorro. So yep, Zorro is somebody with that rod stuck trying to get it off. Pro tip: if you do stick your rod, unhook your electrode holder and then take it off. Don't try to take it off with the electrode holder. Will just cause more of a mess. That's a bad habit. All right, that would be it. So if you have any more questions, you need anything, let me know. If you need anything from MO2, here we are. And yeah, looking forward to seeing you next time. Thanks. Bye.